Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. As we have developed our power supply section, now we will develop different sections of our RTU. First of all, we will place LCD display and microcontroller on our Vero board. Here we have a 20x4 LCD display. It has 20 columns and 4 rows. Here we can find the interface connector for this LCD display. It is a 16-pin connector. Here we can see the pin number 1 is on the left side and pin number 16 is on the right side. We can find the details of this connector in our schematic. Here we can see pin number 1 is ground, pin number 2 is 5 volt, pin number 3 is V0, that is contrast for this LCD display. Pin number 4 is RS pin, pin number 5 is RW, pin number 6 is enable, pin number 7, 8, 9 and 10. These pins will remain unconnected in our circuit because Micro C and Flow Code compilers don't use these pins, and both the compilers, that is Micro C and Flow Code, provide us the interface for this display on 4 pins, that is pin number 11 D4, pin number 12 D5, pin number 13 D6, pin number 14 D7, pin number 15 is anode for backlight and pin number 16 is cathode for backlight. Now we'll place the LCD display on our Vero board, then we'll place microcontroller on Vero board. Here we can find power on reset and manual reset for the microcontroller, and here we have oscillator section. First we'll place LCD display on Vero board, then we'll place microcontroller on our Vero board. Let's start with LCD display. We'll place the LCD on top left side and we'll place the microcontroller under this display. Here we have a 40-pin base for microcontroller. We'll place this base under this LCD like this. By placing LCD and microcontroller in this way, we'll have some space to place different components under this LCD. Here we can place different components like our analog circuits. So we'll place the LCD display on top left side of our Vero board like this. For interfacing of LCD display, we will use female header pins. Here we have female header pins. We will use 16 female header pins to connect this LCD in our Vero board. First, we will insert the LCD in this female header connector. Now we'll solder the LCD in Vero board. First, we'll connect pin number 1 and pin number 16 in our Vero board. Now we can check the position of LCD on our Vero board. LCD is properly inserted in the Vero board. Now we'll connect rest of the pins. Now all 16 pins of LCD are soldered in Vero board. Now we'll solder the base for microcontroller. Here we'll place the base for microcontroller. For this, first we will remove LCD. Here we have placed the base for microcontroller. Now we'll solder the base in Vero board. We will solder only 2 pins of this base on one end and the second end. Now we'll check the position of this base in Vero board. Here we can check the base is properly inserted in Vero board. Now we will solder all 40 pins. Now we have soldered all 40 pins of this microcontroller base. Now we'll connect power supply and ground connection for this microcontroller, and we'll also develop oscillator section and power on reset section for this microcontroller. As we can find, for U5, that is PIC16F877A microcontroller, pin number 11 is 5 volt and pin number 12 is ground. Similarly, pin number 32 is 5 volt and pin number 31 is ground. First we'll connect 5 volt and ground with microcontroller base. To connect the ground and 5 volt with microcontroller, we will use this wire. This wire is used for wire wrapping purpose for prototypes. Now we'll develop proper route for making a bus for our microcontroller for different connections, that is power supply, ground and other connections with different components. We will use these cutting ends for different components to make the bridges for wiring. For this, we will bend these pins like this and we will connect this bridge in Vero board. Here we have connected a bridge in our Vero board and will pass different wires as bus from this bridge to the microcontroller. Here we have soldered the wire bridge on our Vero board. Now we will connect different wires through this bridge to the microcontroller. First we will connect 5 volt and ground using this bridge. First I will connect pin number 32 of this microcontroller with 5 volt. Here we have a notch on this base. On the left of this notch is pin number 1 and here we have pin number 20. Pin number 21 and pin number 40. So we can find the pin number 32 on the right hand side of this base. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 and 32. Now we'll insert the wire from pin number 32. Here we will insert the wire from pin number 32. And through this bridge we will connect the wire to 5 volt. We'll connect this end to the 5 volt. Now we will arrange the wire in a proper manner. Now we'll solder the wire on pin number 32 of the microcontroller. Now we have connected the wire on pin number 32 of the microcontroller. Now we have developed a proper route for the 5V connection for this microcontroller, and we will check the continuity of 5V to this microcontroller. Now I will place one probe of multimeter to LM705 output, and I will place the next end on pin number 32 of the microcontroller. Here we can find pin number 32 is connected with plus 5V, that is output of LM7805. Now we'll connect the ground for this microcontroller. For this we will insert the wrapping wire from pin number 31 of this microcontroller. Here we have pin number 31. Again we will pass the wire from this bridge. And we'll connect the wire to the ground. Now we'll make proper route for this wire. Here we can see we have developed a proper route for the ground connection. Now we have connected the ground of microcontroller with the ground of regulator, that is LM7805. Now we'll check the continuity of the ground connection. Here we can find ground of microcontroller is properly connected with the ground of regulator. Now we'll check the short circuit for power supply and ground connection. For this I'll place one probe of the multimeter on body of LM7805 and next end on pin number 32 of microcontroller. It means that supply and ground connections are not short circuited. We can check pin number 32 and pin number 31 also. Okay, there is no short circuit between ground and supply connection. It means that we have connected ground and power supply connection of microcontroller properly with the regulator. In similar way, we will connect different components with our microcontroller. Now we'll place 0.1 microfarad capacitor very near to the power supply connection of the microcontroller as decoupling capacitor. Here we have 0.1 microfarad 50V capacitor, and we'll place this capacitor very near to the VCC and ground of the microcontroller. We can connect this capacitor very near to the pin number 11 and 12, and these pins are 5V and ground. We'll connect this capacitor under the base to save the space for our prototype. And I'll place the capacitor very near to pin number 11 and 12 under the base. I have placed the capacitor like this. Here I have placed decoupling capacitor for microcontroller very near to pin number 11 and 12. Now I will connect pin number 11 and 12 with pin number 31 and 32 to provide ground and power supply connection to the pin number 11 and 12 of this microcontroller. Here I have connected pin number 32 with pin number 11. Now I will connect pin number 31 with pin number 12, as pin number 31 is ground and pin number 12 is also ground. Here I have connected pin number 12 to pin number 31 and both the pins are ground. Now we'll check the continuity of ground and power supply connection. Okay, there is no short circuit between 5V and ground. It means that we have connected power supply with our microcontroller properly. Now we'll develop oscillator circuit, power on reset circuit and manual reset circuit for our microcontroller.